If you've ever been seriously ill, you're likely thankful for antibiotics. However, they can have side effects, and we're seeing more and more antibiotic resistant bacteria, which has researchers busy trying to find some solutions. Joining me is Dr. Sophie Kerneis, a microbiology researcher at Lethbridge College. Prior to moving to Lethbridge, she was a tenured research scientist at the Pasteur Institute in Paris, where she developed a unique experimental model of a cell in the intestinal tract. Her published work is used all around the world, and we're so happy to have her with us today. Dr. Kerneis, thank you so much for joining me. Welcome to the show.
Thank you so much for the invitation.
Absolutely. So first of all, can you explain what antibiotics are and how they're typically produced?
Okay, so antibiotics are molecules, drugs, like penicillin, for example, that are used to treat some bacterial infection. So it's something that is very important because if you have an infection due to a virus, for example, you will not take an antibiotic. These molecules are produced by bacteria and fungi. And so probably you have heard about penicillin produced by fungi or tetracycline. So this is what we have today on the market. Huh?
So can you tell us why we're seeing an increase in antibiotic resistant bacteria? Why is this such a problem?
It's a big problem, and so I know that today we have a pandemic due to this coronaviruses, but the World Health Organization is basically pushing and to do something to avoid having another big issue with this antibiotic resistant crisis. And so the antibiotic resistant bacteria, first they were always present on Earth. Even Alexander Fleming, who discovered the first antibiotic, the penicillin, was able to see them and to see this problem, but it was very, very mild. This antibiotic resistant bacteria are bacteria that are not killed anymore by the antibiotics, and it's because they have mutations. But the thing that we have today is that because we have used antibiotics since 1940, so a long time, we have selected antibiotic resistant bacteria, and we have more and more. If we use more antibiotics, you will select more antibiotic resistant bacteria. And this bacteria, I need to add two more things. One, they divide very quickly. So for E. coli, it will be 20 minutes. So imagine that. And the other thing is that they have a very big, high plasticity, genetic plasticity. So they can exchange genes basically between each other. So if you have one bacteria that is resistant, it can go to another kind and another kind. So it's why we have now today with this big crisis due to this antibiotic resistant bacteria.
That is fascinating stuff for sure.
Yeah,
Yeah.
yeah.
Now, for the last number of years, you've been leading a project at Lethbridge College called the Antibiotics Alberta Plant Project, which is focused on studying plants native to Alberta to see if they can be used to produce new antibiotics, right? So what specific types of plants are you looking at or looking for?
Well, I would say, all the plants that we have here could be interesting. And the reason for that is that, as I said before, the antibiotics that we have on the market are only produced by bacteria and fungi. And everyone knows that plants have been used in a traditional way here by the First Nation people, but all over the planet, they were using the plants to treat, their disease, infection, or other disease. And so we took this approach of saying, okay, now we should take the plants and try to see if we could isolate some molecules, and that could be the next generation of antibiotics, because as we discussed before, antibiotic resistant bacteria are a very, very big problem. And one of the solutions is to find more antibiotic, new ones, because it's kind of a run, the bacteria are we will select more and more of these antibiotic resistant bacteria. But if we have more and more new antibiotics, we can basically face these issues. So yeah, so
Oh,
any plants are
yeah,
could be a good candidate.
definitely. So you were mentioning that they were used by Aboriginal people to treat sickness. So do we know for a fact if some of these plants were fairly effective?
So there are some reports and it's First Nation from here or in Canada or around the world. So yes, absolutely, they were using some plants like clover to treat certain type of infection. So of course, at before we had not this test to say, oh, we have an infection that is due to a staphylococcus or something like that. So, but because wound, easy to see, it's for us, it's a bit easier than to say, okay, they have been using these plants to treat wounds. So we can suppose that this was because they were due by a bacterial infection or a fungal infection also. So we will basically, use this information and to guide a bit also our
Yeah.
research.
Okay. So how can you determine whether or not a plant will be effective?
So we have some techniques that are now in the lab. They are well established in the lab. So we have been using these techniques since 2016. So when we started the project at the college in Lethbridge, and so in a very simple way, you need to put a bacteria in contact with a plant. And we have a way to find out if the bacteria is growing. It's by measuring the optical density, but it's okay. So we can put the bacteria and the plants together and follow that over a period of 18 hours, for example. And then we can see that certain plants are basically avoiding the bacteria to grow completely. So you will have the same kind of result as the one that we could get with a known antibiotic like kanamycin that we use as a positive control. So the technique is in place, and we have students helping us to do that.
That's incredible. So what kind of progress have you made so far? Have you found any molecules that could be used as
Yeah, we
antibiotics?
found yeah, we found some molecules. So this is also in collaboration with chemists. So we have a collaboration with Professor Raymond Anderson in UBC, who is helping us with this part of the project because in science everyone has their specialty, and so is the plants that are the most interesting for us are sent to UBC, and then they do the fractionation, and we were able to isolate some molecules from some interesting plants. So this is one of the contribution that we hope to get. So from all the plants that are tested positive for different bacteria, then we hope to get more and more molecules with the hope that after we will have an antibiotic.
That's fascinating. Now, I understand that you've found a new phenotype introduced by plants. So, what is it and how can it be used for our health?
So this was observed more recently. So it was with students that are working in the lab. We observed that for certain plants, we see something that we call the clumping. Like an aggregate, like a big chunk of bacteria sticking together kind of around the plants. And so we have a student, Nadia, and who is from the University of Lethbridge. She's doing her own thesis with us, and she is very interested, and she wants to continue doing a master in the lab, so it will be great. And so we are studying this new phenotype as it would be interesting for different applications, such as trying to remove bacteria in the water. The contamination in the water, for example, in feedlots, but also the water that we have in the river could be eventually more clean with plants that are clumping, the bacteria, maybe over application in cosmetics. So this would be some opening for the future.
Right. Now, we're of course in southern Alberta, which is, you know, agriculture is a huge industry here. So, can you tell us about some local plants that apparently contain phytobiotics, which can be used to naturally promote growth in certain farm animals?
Yeah, so this is another. So we have different direction in the lab, and one of the direction is the phytobiotics because basically, to give a very quick definition, they are plant extracts that have some activities, and so we are looking always for antibiotic activities. So we it's known that some plants like oregano or thyme are used to prevent the infection, and we want to basically bring some new phytobiotics from the plants that are growing in Alberta, but also the plants that are given to the animals. And the reason for that is that the farmers don't have access to antibiotics since 2018 to prevent the infection as they were doing before, which is causing quite of some issues because the antibiotics are helping them to prevent infection and also to promote the growth of the animals. So by finding, and we have many plant extracts that are active against, for example, Staphylococcus aureus, that is one of the bacteria that they want to control. We want to bring that to the farmers that they can continue to produce the food, the food animals, or to produce the proteins that we need as for to feed us basically. Yeah, so this can be an interesting project to start.
Yeah, absolutely. Now, Dr. Kerneis, your research also has the possibility of using plants to make natural preservatives for cosmetics. So, which plants would be used for this, and what is it about them that would act as a preservative specifically for cosmetics?
So yeah, so cosmetics. So we are in collaboration with a small cosmetic company in Alberta, and so we are thinking and exchanging this problem that they have. Cosmetics is we put makeup and cream, and so you will basically put your hands on the cream and put that on your face, and your hands are containing a lot of microbes. So basically, it will contaminate the product that can have some effect on the life shelf of the product, and also can eventually cause some infections. So they are using preservatives in their products like paraben, but we want to try to find some more natural approach for that. So bringing the plants that we have found in the lab that contain some antibiotic activities to them, and putting that in their product. So we hope that in the very near future, we will be able to bring that and have a line of cosmetics containing some natural product coming from Alberta. So this could serve the cosmetic here, but after that maybe a bit wider around the world.
Oh, yeah. Well, I would be all about that, obviously.
Yeah, I think it's what the people want to go more natural, not having some chemicals that can
Mhm.
cause some issues.
Yeah, absolutely. So, any idea how
Yeah.
long this process would take to find these, natural effective antibiotics? How long would that take?
Well, depending. If it is an antibiotic that, like penicillin, for example, just to give you an idea, for Alexander Fleming, it took him 12 years, which was the first thing was because, this was the starting point. So he had to convince people. But, and we see with coronaviruses, with the vaccine, it takes time to put a drug on the market because we want to make sure that it's really, really safe. So maybe it will take normally it's about 10 years. But I think it's still very important that we start today to have some antibiotics in the near future. If it is phytobiotics for animals, I think it can take much less time. We hope to, feed the animals with this product, with these plants. And for the cosmetics also, maybe, I don't know, maybe 1 or 2 years, and we will have some plant extract in the for the livestock or for the cosmetics.
Yeah, that would be so interesting, especially if we can see it available at our local pharmacy. So even in terms of a plant-based antibiotic, any idea as to how long we can see that available at our local pharmacy?
I don't know, hopefully 10 years maybe. And we have to start, and this is the World Health Organization who is pushing to say, okay, we need to find new antibiotics, because the pharmaceutical industry basically quit a bit this topic because it's not very rewarding in terms of money. You develop an antibiotic, it's quite expensive, and then you will have antibiotic resistant bacteria coming up quite quickly. But still, we don't want to arrive to this situation where they say that if we don't do anything by 2050, we will have 10 million of people dying of this antibiotic resistant bacteria, which is huge. Today we have 700,000 worldwide, which is a lot, less than what we had for COVID. But we need to do something today. And
Absolutely.
so
Yeah, absolutely. It's amazing. Thank you so much for your expertise, Dr. Kerneis. Dr. Sophie Kerneis is a microbiology researcher at Lethbridge College. Thanks for joining us today.
thank you, Janet.